Okay, I think we can slowly get started. I know that this is fairly early in the morning, especially for a technical conference, so I'll try to be light on everyone. Also, we all know that live demos sometimes work. Most often than not, they fail. I will try to attempt some live experimenting to show you guys the stuff that I'm actually talking about. I'll try to structure it in a way that I'll have probably something like 30 minutes worth of slides and probably equal or even less amount of stuff to show. But on top of that, I would like to encourage everyone to ask questions or have a discussion. Most of the things that I will be talking about are not things that are already set in stone in the Drupal world. The concept of automated testing and building, although have been in the Drupal ecosystem for a long, long while, things have been shifting so rapidly that there are really a lot of solutions out there, but there is no de facto standard and the best breed of solution. Every approach has its upsides and downsides. So I'm actually really, really curious what you think about the state of those processes currently. What you use in your organization or your daily workflow, what works for you, what doesn't. I really hope that at some point in the next 1 or 2 years, the Drupal community will establish what will be kind of the best practice. And I have some tools in mind, but I could be wrong. I've been wrong before. So how many of you are Drupal 8 coders? Or you would say you're intermediate or advanced level with Drupal 8 backend? Okay, and how many of you have worked with Drupal 6 or before? Right, that life was so much more simple than it is now. All we had to do was just use this horrible, horrible tool called CVS, which was a version controlling software. It was pretty difficult to use. But if you use it, you already had an advantage over those people who were FTPing their code up to whatever server they were using. Branching wasn't really solved, and stages for contributing code back. And essentially what you had at that point was you built something on your laptop, you add it to your repo, and you commit it. And that was it. So there's nothing really complicated about it, and this is more of a Drupal 5 era that I'm talking about, so it's more than 10 years ago. But still, you collaborated on something, you put it under version control, and poof, it was live. The stuff that you were actually working on was the same thing that was running on any of the live environments that you were working with. Now you can of course complicate these things and work on the collaboration, introduce staging and testing. SVN came along at some point, which made life somewhat easier, but if you remember SVN, you all use Git, right? So you're all pretty familiar with how Git works and Git branches and whatever. Now, branching in CVS was already a pain, and that's what SVN did when you tried to branch or tag things. It was actually copying all the files into separate directories. Now, Drupal is known for a lot of things. Not having or having few files is not really one of them. So you could imagine how much of the pain that was when you were working on a large site with hundreds of modules or themes that simply just branching was a huge pain in the ass and time consuming. So obviously you can add some stuff to this, but had its limitations. But bear in mind that this was a long, long time ago. Things have changed so much since then. I mean, 10 years ago, I think that was when Drupal 7 came out, or 6? Anyway, I think Drupal 7 came out was when iPhone came out. So we're talking about an era that was, people were born after that and they already do Drupal, so it's been a while. But it got us to a certain extent, and we as a community identified a lot of the shortcomings and things that we have to work out how to do better in the upcoming versions. For instance, configuration management. There's actually a link to Ethan's slides in that CVS, but if you search Ethan's presentations, then he actually has a really nice set of slides about how this whole deployment management and collaboration worked. 10, 15 years ago. It has a lot of best practices that are still valid today. For instance, the usage of update hooks to manage schema changes in your application, or the importance of testing. I think there are at least 2 or 3 slides in there that just have the word test on it. I cannot imagine what he was talking about then. And we also had some notions of configuration management. It was not CMI and it was not Drupal 8 fantastic YAML files. It was export this text, which is actually a PHP object, and that you can import it into your other sites. But it was kind of, the notion was there, and people have realized that in order to have right staging of versions of applications, so you create something and then you test something and you push something live, in order for that to be repeatable and testable, you need these things, and those were the areas that then the Drupal community identified and started to work on. Now, with the advent of Drupal 7, we had a really cool thing called Drush Make, and since I think most people here have Drupal 7 experience, you have probably heard of Drush Make, which was an amazing tool because you could just take a make file, say Drush Make, and your whole doc route was built. So it allowed us to have, in any repo or in any collaboration platform where we need to manage some code, it allowed us to have only the custom stuff, only the stuff that we wrote to be in there, which made it really easy to replicate it, to recreate that artifact, that thing that runs your website, your application, possible. And yeah, it was a really nice, repeatable and testable process, made upgrades and fixed version releases easier. You couldn't just go in and do, well, you could still do Drush update, but it didn't make sense because you were controlling all the versions of libraries and modules that you're using through Drush Make. And kind of this process of, now I only have my custom code in the repo, and I have a process that turns that into kind of an executable, oh, it's not binary, but something that can run from something that cannot run. So this whole notion of continuous integration was kind of introduced to the Drupal community. And the Drupal community has been lagging behind for a long, long time behind the PHP world. If you think about when Drupal 8 was released, Composer was still not a thing for Drupal. It was introduced a bit later, and it was not that standardized. I still see some Drush Make YAML files in some of our legacy D8 projects. The PHP world, in terms of available libraries, exploded because of Composer and packages. So you have so many packages and so many third-party software that are just not Drupal specific. So that already now, when commerce guys are working on Drupal Commerce 8, or for Drupal 8, they're primarily focusing on third-party PHP libraries, and that's kind of how the Drupal community started to get off the islands, to start using all of these third-party tools, as opposed to our kind of in-house, ingrown things that just live on Drupal.org. We still had a lot of dangerous precedents before D8, of course. I'm sure that many of you have seen cross-site scripting vulnerabilities in template files, or probably you've seen things like SQL queries in template files, and all of those things were enabled by the tool set that we were using. Drupal 7 didn't really use any of the modern templating tools. Twig was available by then, but because of all the ways that Drupal is evolving, it was just not there. With D8, that finally came along, and funny enough, all of those typical vulnerabilities like cross-site scripting, for instance, is almost completely gone now. So even if you do not really know how to do clean PHP code because your prime skill set is creating fantastic templates and creating fantastic CSS, but maybe you're not really aware of the security implications of printing out a raw variable, well, Twig solves that. And these are not things that are realistic to expect from everyone. And Drupal has done the best to cut down on that barrier of entry and to cut down on how easy it is to make a mistake. We did a few things great, though, already in Drupal 7, and by we, I mean the whole community. For instance, the introduction of the whole object-oriented database layer. That saved us from a lot of the pain, a lot of the SQL injection problems that we had when people were just concatenating strings and then passing it into DB query, which is still somewhat a problem. We had Drupalgeddon, but yeah, we recovered from those minor hiccups. And Drush Make was still good. So I'm not saying that all of those things were really bad and we screwed up, but I think it's fair to say that when Drupal 8 came out, Drupal was already behind where the world was in terms of technologies that it was using and approaches and stuff. Yeah, one of the best things was, for me, that we had the really funny alias for features revert all. We had stuff like installation profiles as well. But now Drupal 8 came along. And with that, a much more reliant system on third-party libraries. So just using Drush Make, it doesn't make sense anymore because you have so many other libraries. And since you're already using the same language, the kind of the similar platform, this notion was born that we should just manage everything to Composer. We should forget about Drush Make. It served its time. And now we need to move on, get off our island and use tools that are standard in the wider community and in the wider world. So Composer was also introduced to Drupal 7. How many of you have used Composer for D7? I'm sorry. It's a pain, right? It's a huge pain in the ass. It was not designed for that. You can use it, but it's not ideal. So Composer has Composer is kind of a dependency management tool where you define in a standardized way information about your project, whether that's a Drupal module or a library or a theme or whatever. You store it in a Composer JSON next to your project code base. And when applications refer to other applications, they look into this Composer JSON file, determine the dependencies stored therein, and then they can move on. This is, for instance, the Composer JSON file, which is packaged with the mobile detect module. And you can see, for instance, the third-party library dependency is defined here in the required part. And you can get a lot of really nice semantic data out of these files. For instance, how you can contribute and where it's maintained and who's maintaining it. And some of that is not really present anywhere else. And actually, it's something that we could, in the future, maybe replace even our standard info files with. But this is just a side thought. So there's a tool that allows us to really nicely build our whole website. And by building, I mean something a little bit more complicated than just downloading a bunch of PHP files and libraries. Composer is also a very powerful building tool. And again, I keep repeating this building. What building actually is effectively turning something that's kind of a developer collaboration artifact or a bunch of custom code that you're collaborating on into something that can run, that fulfills that business value that you set out to do. Now, in very simplistic terms and in a typical use case, that means you have maybe a custom module that you're creating, a Composer file, but what you really want to have is a website that runs. That needs a lot of steps. You can't just download a bunch of PHP files. If you think about it, sometimes there's front end. Sometimes you have to work with designers. There's SAS files that you need to turn into CSS. And then there are all those JavaScript guys creating all that crappy code that they want to turn into compressed JS files. And then you have people who are constantly making mistakes so that you need to validate that the coding standard is up to date. So then now you also have to do linting because you can't really collaborate if people are fucking up the coding standards. So Composer also has some abilities apart from just managing dependencies. You have the ability to alias scripts to say, for instance, in example is defining a script alias for just lint, which is then of course referring to some other things, but the point is that you don't have to use any other tool to run lint. You don't have to remember what your linting command is going to be, because your project already contains that information, and all you have to say is composer space lint, and then all that predefined scripts are going to run. So it's an extremely powerful tool. Yeah, Bill, this is something we've talked about. So now we have a bunch of things. We can do a few of these with Composer, right? So we can have the Drush Make kind of capability. We can get the patching. We can download whatever libraries we want. We can check out from Git. We can check out from even the local file system. So that's great for the PHP part. But we still need to compile our SAS files or LESS files. We need to minify the JS. We need to do other things. We may need to run. It's just linting that you probably want to run. Maybe you have tests in your projects and you're one of those good guys. Then you probably want to run PHP unit or unit tests on your JavaScript stuff. So suddenly we have a lot more and complex steps that we need to take than just build, download, and execute a few shell scripts. It depends on a bunch of other things as well. And you may want to consider actually building different things for different environments. Like, are you going to really need PHP unit for your live environment? Probably not, so why have it? So then you need things for development. Maybe for development, you don't want to have your CSS files compressed because it's going to be easier to debug. So when you have your normal development workflow set up, that you have a local site that's running, that's where you hack it to bits, but then you have a shared staging or development instance, that's where all the developers are going to look at it. You may have different business priorities for those environments. Obviously, the production is going to be the cleanest without any developer tools, CSS minified and JS minified and whatever else you want for that production environment. Not to mention, obviously, the settings and configuration, but that's a different story. So as soon as you have that, you need to have a tool that allows you to easily compile these build steps. So you should be able to say that, well, in order to create a local environment, I first want to run Composer install, and then I want to run this and this and that. You also probably want the capability to say, well, if this failed, then do something, like roll it back, undo that damage that you've done. So for front end and themes, Gulp and Grunt has been pretty much around for a while now, and people have been using very happily. It's easy for front-end developers because it's JavaScript based, and I've seen people trying to standardize on Gulp and Grunt for the whole Drupal build part of it. But somehow this didn't really take off, at least not to my knowledge. And this is a point where if you feel differently, or if that worked fantastically for you in your organization, then I'm more than happy to hear about it, because I think it's a fascinating topic how fragmented this landscape is. So the thing has been pretty much the standard, at least what I've seen. But developers often hate it because Thing uses XML files to configure those build steps, and some people don't like XML files. It's not too readable, it's difficult to use with an IDE, and so on. And lately, Robo came along, which is a PHP-based building framework. And it's actually pretty strong. It gives us the ability to code our build steps, and probably a backend engineer or backend developer is going to do that in the same language as you're creating your application. So it's very close to your heart. It's object-oriented. The concepts are really strong. It's actually a really nice tool once you start using it. And with that, I would like to jump into a tool that is building on these frameworks, or at least it used to be built on Thing. And now it's built, they've moved all the code out of the XML files and converted into Robo PHP files. And this tool is called BLT. And although, I mean, why yet another tool, right? I mean, we had Thing, we had Robo, and all these tools to do our bidding, but we still need something that's a bit more standardized. It's something that you want to hand over from project to project, and projects are not going to be the same, right? So you probably want to have your building tool you're building scripts, your XML file that's describing what to build and when, to be adaptable, to be configurable. And then you start thinking about a general framework of building scripts and building tools. And this is what Acquia did. It used to be called Bolt, and then when there was a huge outcry from the Bolt CMS, they renamed it BLT. But the name doesn't really matter. And frankly, the company behind it doesn't matter either, because it's all open source and everyone can just start using it. There are no tie-ins or requirements to use any of the Acquia platforms. Obviously has strong integrations with it, but it's not depending on any of it. And we've introduced that in our projects as well, partially as an experiment, because we used to use, Thing. So we had a kind of like a 900-line long XML file that contained all the build steps. So every time you wanted to modify something, you had to go in and understand what that was doing. And if there was a dependency to build X, Y, and Z, you wanted to replace that, then you build something completely custom for that particular project. Because BLT is basing its logic on Robo, it's actually really easy to extend and alter steps and hook into processes, hook into parts, and just execute your own custom stuff. So you don't have to change the underlying system. And it gives a framework of project-based collaboration to everyone involved. So when you're starting up a project, how many of you had this problem that, okay, so guys, what was again the place where we put the doc root? Like, how do we name our Git commits, and what's our commit template so that we can link it with our issue management system? And how did we integrate again with this funny CI tool? Like, all of these things come up. These are kind of standardized internal process questions. If you have a new project, and what's your naming convention? Where is your doc root? How you're building it? And all of these questions again and again and again come up. And this is where a project template comes in really handy, which the BLT-project project can help us do. So as soon as you execute that, you'll get essentially a project initialized for you. It's going to have a doc root, it's going to have all the default BLT scripts and a vendor directory and all of that. Has a project-specific YAML file, which allows you to configure what environments need what modules to be enabled or disabled, what your project namespace is, what the project key should be, and a bunch of other things I will show you in a second. And after that, if you're choosing to use a local environment, all you need to do is just set things up, initialize the settings files that will be automatically included, and you're done. BLT setup will take care of all the composer install and related steps. And at the end of the day, you're going to have a running Drupal site. And after this presentation, I hope that that demonstration is not going to fail too terribly. So in theory, at this point, we are going to have a build. So we're going to have a website that runs, which is good to have. It's partially why we get paid. But it's not enough. We all make mistakes, some more, some less frequently. But there are things that don't, or at least when they do, it's kind of replicable. And those things are the machines. So we have a bunch of steps that we can take to automatically ensure that whatever we're building, whatever we are creating is up to certain standards. And who hasn't heard of testing here? Anyone doesn't know what testing means and why it's important? Right, so we all know that testing is key, right? It's improving the standards and the reliability of the application that we're doing. And we can do a bunch of stuff, like we can lint, we can check if the coding standards were kept, which ensure that we can collaborate on the same project and it's not going to look like complete crap. In some cases, like if you're building a project with the install profile approach, you probably want to have that website installable at all times, right? So you don't want to introduce a change that will suddenly break your build. And if you're depending on that, if your staging is basically just a Drupal site install with a default profile, then you want that to work. So that should be automatically tested and repeatably tested. Unit tests, if you're creating a complex piece of functionality or integration library, you probably have parts that you can test so that You put in some data, you get some known data out, and an integration test, and so on and so on. As soon as all of these have passed, at least with a reasonable certainty, you can state that this application is as cool as it's going to get. Obviously, there may be some manual validations of certain things, but then the question is, right, so we started with, we can collaborate because we've got our custom code. We have a tool that builds that, so we have a website, but it's all, at that point, it's somewhere. We haven't really placed it anywhere in the world. When, well, not when, but, well, when is also a good question, but where are we going to do all of that? And we have so many options, and this is, again, one of the areas where I feel like we still haven't established any standard at all. And again, this is one part when I'm looking at you to shout out which one sucks the most or least. Because we can run, everybody knows, we can run a local LAMP or AMP or MEMP stack, basically native Apache or whatever is, or Nginx, whatever you want to use. MySQL, PHP is on your laptop, on your server, you're running it, you're happy, it's fast, it's good, it's efficient. There are online tools that you can easily integrate with GitHub, Travis, Circle CI, that will do that kind of pseudo virtualized environment for you. You don't have to worry about using your local resources. But then all of the big players, Acquia, Atlassian, have their own integration platform, obviously, that they can get more money off us. GitLab, how many of you are using GitLab? Cool. So GitLab has a pipeline built into it, which is pretty awesome as well. So pipeline is essentially triggers off the script, will read a YAML file and run whatever commands it finds in it. Essentially like our build scripts approach was before. And then you obviously have Jenkins, which can do pretty much the same thing, but it's a dedicated tool. It's really powerful as well. So it may not be the best. So pros and cons. LAMP stack. It's fairly easy to set up, right? It's okay-ish. You have a lot of possibilities to follow. You can use MacPorts, Brew, use the native stuff, or use just simply MAMP or Acquia Dev Desktop or whatever tool that you want to use. But still, the problem is that unless you're really, really filthy rich, or the company is, then your limitation is going to be the hardware that you're running it on. You can't really get a laptop, an Apple laptop with more than 16 gigs of RAM. So running builds and all of that stuff is going to take up resources that you're currently actually using for work. So you're trying to be productive, and then you have to step away for a coffee because you have to wait until stuff compiles and downloads and builds and tests and integrates and does all the magic. So although it's fast and it's efficient, but it's still not ideal. Plus, huge downside is you can't really run PHP 5 and PHP 7 at the same time, or at least it's going to be very challenging. You can switch, again, with some technical skill set, but it's not an easy thing to do. And even with MAMP-related things, we had incidents where one of our colleagues switched it from PHP 7 to PHP 5 for some reason, and the whole thing just crashed. So obviously, it's even with dedicated tools can cause concerns and issues. And this is actually a circumstance that we cannot really forget. Unfortunately, we all live in the real world. And we have to sometimes use PHP 5.6 or whatever. We can't just use PHP 7 at all times. Sometimes we are restrained because our clients have a server and that runs PHP 5.6 because of a legacy application, whatever. We're tied into certain circumstances. So we're not absolutely free to choose the environments that we are going to run our application on. And if we can't do that, then we can't really choose our development environment either, because if we are not developing at least a very close approximation to what we're going to run or go live on, then inadvertently we are going to introduce bugs, we are going to face issues if it's not the same PHP configuration. You know, the shorthand notation for opening PHP is, it can fail, like if it's not the same configuration for if that is accepted or not. I think by now it's completely removed from settings. I remember I had a huge problem of that a few years back. So it's ideal if you get close to a live environment, but you can't really do that if all your projects are different. So it's a challenge that we need to solve. Now, all of these virtualized remote resources and CI tools, like Travis CI, which is really popular, and all of these are very good, so I'm not trying to talk crap about any of these solutions, because under certain circumstances, they're all valid, they can all be good. It's really difficult to figure out what's best for everyone, probably nothing. So Travis CI, Circle CI, and all of these pipelines-related projects, pipelines named projects, they're all really good. Essentially what they do, they spin a virtual environment up for you, and they, again, run those commands, the basic shell commands that you gave them. Obviously, they cost money because you're using someone else's resources, so that's going to be a problem. And they can be slow, as in really slow. If you have, for some reason, if you say we wanted to test your Drupal application, a medium complexity Drupal application with not much front-end compilation can take up to 10 minutes on Travis, for instance. And if you have a lot of developers who are working together and you really need that merge request or pull request to come in and you still have to wait for that Travis build to succeed, it's going to be a pain. And then if you start adding multiple platforms, maybe you want to test on PHP 5.6 and PHP 7 because you're just really tedious, then again, it's an extra time allocation. And again, they cost money, so you have to bill that onto your customer in a certain way. So then it impacts your business and all that. But on the plus side, they run overnight, unlike your laptop probably, unless you're on call. And you don't have to worry about executing those really long integration tests, those front-end tests and all that. So there are upsides and downsides to everything. Now, there is one compromise that solves kind of this problem of having multiple environments and different environment configurations, but it's kind of free. And again, free in a sense that somebody has bought that laptop for you. That you're only using for work anyway, so it doesn't really matter. But virtualizing introduces a level of abstraction. So using something like Vagrant or Docker, they're all going to introduce additional overheads and use additional resources to run. It's not going to be as efficient as just running the native LAMP stack. It's just not going to happen. It's not as bad I mean, there's still differences between Docker, for instance, and Vagrant because of its capability, but still, you could expect that it's going to consume a significant amount of resources. And because of all of that, for me, and this is again just my perspective, but I think GitLab is the ideal solution to this problem. It's, in my opinion, the most cost-effective. And this is all free, like the GitLab Community Edition is all free, and that's what we're using at Shepherd's as well. First of all, for a small organization like 10 to 50 to even to 100 people, you get things like project and repo management out of the box. And by the way, it's not meant to be a pitch for GitLab or anything, it's just this is what worked the best for us. So you can manage contributions, the same thing as with on GitHub. You have pull requests. Now they call it merge requests just to be special. You can delegate membership responsibilities on the projects. You can delegate who is owning it, who can commit into the master branch, who cannot, and so on. And when, for instance, what should be tested on merge requests and when that should be allowed to be committed, and so forth. Very strong integrations out of the box with Slack or Redmine for those unfortunate to still use it, like us, but also Jira and other tools as well. But most importantly, it has a built-in CI kind of platform called pipelines. And what this allows us to do is to do all of that stuff that I've been talking about until now. So you can define what stages your application is going to be built in, what commands need to be run when that build happens, and then what happens after that. So should you be allowed to deploy? and so on and so on. In addition to that comes the question of if we want virtualized environments. For instance, the GitLab pipelines is a good example because you probably want things like different PHP versions or different Ruby versions. So those are a nightmare as well. And then you need some virtualization. You need that particular software. There's just no way around it. And Docker has received a lot of hype. How many of you are using Docker for development? Okay, how many of you hate it and love it at the same time? So it's, I don't know, it has its downsides, right? But also, it's extremely good in that you can replicate a target environment, a certain environment, exceedingly well, and it's still fairly light on the resources, like compared to a Vagrant or VirtualBox instance, it's still not as heavy. So what we've set up, and we've seen that a lot of other organizations do as well, is just simply run Docker on their GitLab pipeline server. And when you're kicking off a job, then you're effectively just spinning up and building a Docker instance and running that. Yeah, and since that's fairly lightweight, I mean, depends on all the stuff that you're compiling and building into it. But unless you really need like Ruby dev for some of the crazy things that you do on the front end, your typical image size is going to be a few hundred megabytes, and if you're building something else than Drupal, it's going to shrink even more. So it's highly transportable. You can just grab that image and put it somewhere else. Now, this is a point where I wanted to, this doesn't look that good. So, any questions at this point? Or comments or something? No? Yeah. Yeah.
When you talk about GitLab, would you recommend a self-hosted version or the one that the guys operate in the cloud?
Yeah. So the question was if, since I was talking about GitLab, if I would be recommending a self-hosted version or a cloud-based version. I don't know. It depends on the circumstances. Like, generally speaking, I tend to be in favor of I rather pay for a service and expect that to work than hire someone who has to be managed and whose job is to do that stuff. But depending on your goals, that may still be a good solution. So for instance, at Chep, just as a live example, if I had a developer team of 3-4 people, I would probably just pay for it and have it done. Because those 3-4 people have more important things to do than manage my infrastructure. That's what a service is great for. But at Cheppers, we have a DevOps team as well, and they just love hacking shit. So for them, it was like, they will do that in their free time. I was like, okay, that's good. Still, that implies certain responsibilities on them. So if the server goes down, then I will go to them, and I'll ask them to, remove that thing that probably we did and that broke the server. And we have to then be responsible for that maintenance. So, but in this case, in our case, there's the additional benefit of we're practicing, DevOpsy things. We're improving ourselves. So that's kind of an added value that I would rather not pay for it in that case. But for a smaller team or for a team where there's no DevOps, SysOps kind of person, I don't see why I would need to hire one when I can just pay for the service. So I wanted to show on an example project how this whole structure works, starting with BLT Composer and things like that. And as you can see, I'm not that well prepared in this. So just give me 1 second. Right. So one of the things that, why is this not magnifying? Okay, there we go. So one of the things that I talked about that's, for me at least, is particularly nice about, wow. There's a mouse. Yeah. He wants to hear what I have to say about BLT as well. Well, where did it go? Anyway, Yeah. Hi there. Yeah, he's definitely stealing it, so. Yeah, it's. He's going to Ruben's Porsche. All right. Let's get back in, shall we? So, one of the really cool things about BLT, it's not easy, is kind of standardized naming conventions and how you store information about certain things. For instance, and for me, this is one of my favorite, most obsessive things to talk about, and it's probably the least impactful in a project's life, is how you're marking commit messages. It's like, for me, it's the #1 thing that people can really annoy me with. If you're creating things like commit messages, like changing some CSS or just CSS in a commit message. It's not descriptive of the change that you've made. It doesn't make any reference to the work and the area that you've impacted. It doesn't say anything to anyone who's going to look at that later on. It's a huge, anyway, you can already see that I'm getting pissed off just by talking about it. So one of the things that I always advocate and recommend is to enforce a template for Git messages. Git messages are often used for linking with, come on, are you serious? Let him go. Just let him go. Let him fly away. So linking Git repo activity and history with any project management tool, for instance, Jira, is challenging if someone is not keeping that prefix pattern and doesn't create their commit messages accordingly. So BLT introduced this concept of having a project prefix, which is then enforced onto the commit messages. So in this case, that prefix is going to be mapped with a Jira project, assuming that your repo is set up. So this is just the repo side, the commit template side of things. But Jira usually has a 3-4 letter acronym or a shorthand notation for a project. And if you're using a commit message which uses that keyword and then the number of the issues, then you can automatically link it up with Jira, and it's nice. But you can also define a bunch of other things that can help you with. For instance, this is a file that will get distributed to everyone who's working on the same project. So if we have a team of 4, I don't have to train every single person that your website is going to be located here and there, because that's the host name that we've set up. Or that the project name is X and Y. It's already defined, so you have a really tight control of naming conventions within your project. But also, since BLT supports deployment stages, it can run certain commands based on how you configure your project, what modules should be enabled or disabled on certain environments. And again, this is not something that you need to control very, very tightly on a human level. This is something that can be added into the project. And it often happens that you have a dev build, you deploy something, and oh, well, for me, I had this module enabled, but you don't have it. With an approach like that, this doesn't happen. And you know that if you push to prod, for instance, UI-related modules are going to be uninstalled. That's great. And this directory that I'm actually in is a BLT kind of directory sitting next to the doc root. And it obviously has override capabilities as well, so you can take some of those settings and change it if you didn't want to really convene to whatever host you wanted to run it on. It's going to do that. But for me, one of the most exciting things about BLT was how I can extend the steps that I need in order to build. A typical build is going to consist of, where is the terminal? So this is not that good, but these are all the commands that it's supporting, and the typical install is going to be setup, which is setupable. But as you can see, underneath it has actually a fair amount of subcommands. This is not exactly the command chain that is going to trigger and dependency chain, but just to show that setup itself is going to kick off any behat tests that you may or may not have. It's going to run configuration import. It's going to run Drupal install. Set maybe the hash salt if it exists, and run the toggle modules, which is based on the environment. It's going to enable and uninstall the modules that you want to have or not. So these are all things that are built in, and they conform to pretty much, in most cases, you can map it to a workflow that you normally would have, because these are things that most of us have. However, and this was fairly difficult with an XML-based building tool like Behat, inject something into those steps or change something. And using the command hooks, or well, commands and hooks, you can either define, or you can both define your own command that you want it to run in a fairly easy way. So to define your own command, essentially you define the namespace it's going to run in, using the, there's a name for the syntax that's used here that I forgot, but essentially in a comment, you define what the command is going to be, and you define what it has to do. If you're using a proper IDE, then you can trace back what functions you can run. You can run Drush, anything. So from within, so anywhere you are, for instance, within the project and the project's doc root, you can kick off projects that will, or commands that will be both relevant and functional without passing any further parameters. Just to give you a really, really simple example, if I say I wanted to run Drush, but I'm not executing the BLT build from my doc root, right? So if I wanted to run Drush from outside the doc root, then I would need to pass aliases. I need to let it know where my site is actually at. If I use the Drush command from BLT, then it's going to figure out where my doc root is based on configuration and so forth, and it's going to execute that Drush command on that particular section. Jofi, do you need to hunt for the mouse?
So actually someone is coming.
Okay.
So you might need to take a break. I don't know.
All right.
I don't want to catch it with bare hands.
Okay. All right.
Someone is coming back.
Yeah, I will continue, and if they come, then we can already stop the session. I think I will just have a chat after that, because it's a bit easier that way. And I think I said most of the things that I wanted to talk about. Sometimes you also want to do things without actually creating custom commands or extending it. Like, you know that after I have triggered my whatever installation phase, I want to then run this special command. Just to give you an example of what these use cases could be, we have a project where we, for instance, this is an example of extending that. We have a project where we, for instance, wanted to get content into Drupal after installation. Now, that might happen to some people, right? So we created a custom command for that, a custom build step, which is running Drush, as you can see. But that BLT command can be executed from anywhere within the doc root. It's really easy to extend it. For instance, creating private keys and then updating configuration as well. And I think at this point I will let the mouse hunters take over. No, he has a stare. Okay, okay. It's not going to run for too much longer anyway. So, and these are just a small amount of capabilities that that you can do. For instance, and this is, for us this was incredibly helpful because you don't have to inject or change any of the commands that you're running after your deployment has been built, you can simply run one of these hooks. And just to wrap things up, I wanted to show you, for instance, a GitLab CI configuration file, which shows you how these things would actually impact your work. So this project in particular is using Docker, but probably it's easier to show that on the demo project I've prepared. So if you haven't used Docker before, essentially just a really brief intro, and it's probably going to be inaccurate in some way, but the gist of it is that you have a single text file, you have a bunch of commands that set your virtual environment up with all the packages that you need, and then that's it. You'll have your code in it, you'll have your libraries and whatever. Usually descend these or originated from a base image, a base package, which contains probably some operating system level stuff, and then you define what other libraries you want. And this part really is where the packages come into the picture. You can define, for instance, the PHP version based on what you're installing here. And then all of these extra steps are just to initialize the build. And here's probably one thing that's more relevant for us in the BLT topic. So here we're actually invoking BLT to prepare the build artifact. So at that point, we're going to have Composer is going to be installed, so it has the BLT command and has a bunch of the dependencies, but there are a lot more tasks that need to be run for a Drupal site to be fully functional. And this setup build is going to be the one taking care of it. And if you have a custom step that you want to take or some custom tool that you want to run, then, for instance, injecting it or adding it into the hooks and adding it after a certain command, you don't have to do anything else but just invoke your usual setup build, which ensures that you will have the static stuff ready. And from the CI file, which is then going to be ingested by GitLab itself, you define various things. So, first of all, when you're using any sort of pipeline, you will have various stages for the, stuff happens. And the reason why you have these stages is that you don't want to enter into the expensive operations if the cheap ones have failed, right? So you have linting usually first or unit testing first. And if that failed, then why use the expensive resources? And they should actually, this applies if you're using locally or remotely, because time is a resource as well. If a full-blown front-end test is going to take you half an hour to an hour to run, then you probably don't want to do that if the PHP syntax is invalid in the first place, because that introduces problems on its own. So, in the way we've structured our builds, and this may or may not apply to your use case, is to have 3 stages. And the third one is not in this example, but we have a stage which builds our artifact. This artifact is going to be that Docker image containing the code, but you can just think about it as, at this stage, we are making the application. We are running all the requisite steps to have that code structure ready for deployment. And that can be in a zip file for all I care. In this case, it's in a Docker image, but it's essentially the same. The only difference is that if it's a Docker image, then you also have the environment kind of packaged with the code. I know that this is an oversimplification, but it's still the case. And then once the build is complete and everything is hunky-dory, just one sec. Then we can validate it. We have the build artifact, that's it's going to go live, and then we can run linting. And then this again uses and goes through BLT here and runs the validation step. So all in all, we're using the same tools, the same kind of language to interact with our application. I mean, it's again a new technology, right? So you may or may not have the time to learn it, or you may have vague issues that you need to debug. And in some cases, it's probably, I mean, if you have ample resources, you might as well just use a proper VM. It's somewhat easier to run. So I would say give it a shot, and let's see if it works for you, or you're facing so many uncertainties. You have to keep in mind that Docker, I mean, if you really are nice about Docker, you're not going to use it as a VM. You're going to be using it as a wrapper for certain services. So you're not going to have MySQL and Apache and the code base all in one image. That's not really how it should work. And Drupal is particularly nasty about these things, because if you check this Docker file, I actually have something, MySQL client in here, that I don't think I would really need, except that Drush requires that. So I cannot have Drush unless I have MySQL client, but my image shouldn't really necessarily contain that. So it does invalidate some of the benefits that I want to use Docker for. I don't know. I mean, those of you who are using Docker, would you recommend using Docker? So the answer was that it's recommended when it comes to using testing certain services which are easily Dockerizable. So when you have a dedicated Memcache instance or Solr instance, and it's easy to just use that service as its own Docker container, then you can easily swap it out, right? Okay. Just for the recording, I had to repeat that. Any more questions? Okay. Yeah, let's keep talking about these things, and if you have ideas and criticism of the processes that I've outlined, I'm more than happy to learn more. So I've started to dig into this topic a while ago, and I realized that both from an organizational standpoint, there are challenges around adapting Docker, for instance, to getting the know-how to run Docker. The challenge is when you're not using your favorite tool set. So I know that a lot of people love gulp and grunt, and it's difficult for them to let that go and use something standardized or even third-party. So there are a lot of organizational challenges. I do think that BLT is one of the best tools, especially now. Like this whole robo conversion is fairly new. But with all the tool set and the command definitions and then all the setup that's there, it's an incredibly powerful tool that allows you to create replicable builds and use the same tool with smaller project-specific tweaks and customizations that can be transferred from one project to another. So it's incredibly robust, but flexible at the same time. So I do believe that's going to be, at least for us, it's going to be the way forward, but I don't want to turn a blind eye to anything else that could be a good idea as well. All right, well, thanks very much. I thank the mice as well. And yeah, catch you later. Thanks.